So let's deal with problem C. As you can see here, we have already solved for the free body diagram or sketched the free body diagram, as you can see here from our previous discussion, face to face, and also in the video. Now, our task is to create or to write the summation of the forces, the equation. Now, of course, since this is the third problem already, and I'm hoping you try this at your home. We always start with the sum of the forces in only one direction, in this case along the x. And then we equate that into m a sub x. Alright. So basically again, the m that you are seeing here and then the acceleration along x is referring to the point where you are sketching your free body diagram. In this case, we are talking of the intersection over here. And yeah, the acceleration is the acceleration along that point. Now, what are then the forces along x? So we simply use our sketched free body diagram for that. So I'm gonna highlight the forces that you are seeing along the x. So first force which exists along, or it has a component along the x-axis, is your force bx over there. So I'm gonna write B sub x, so the x component of the tension force B, and also I will add the component of A sub x. Now take note, I will just write A sub x instead of writing this as a negative because I will be utilizing SPA. And if you recall from problem B, we said here that whenever you use theta uh, as SPA, or you measure theta as SPA, you disregard the direction of the force on your free body diagram. And that is exactly what I'm doing here. So again, I am not writing bx minus ax because I will be using SPA. That is just bx plus ax. So what are then the other forces which exist along, or has a component along your x-axis? So clearly there are no other forces except for bx and ax, and that is equal to m a sub x. Now, for your bx, if you recall from problem B or try to check from problem B, just to give you a hint, this one, again and again, I keep on repeating this. This was from our discussion resultant vector. Whenever you try to take the x component of a force, assuming or as long as it's using theta as SPA, automatically the x component will just be the magnitude of the force multiplied by the cosine theta. And its y component automatically again will just be the magnitude of the force F, the sine of the angle theta. Theta is measured in SPA. So that's what I'm going to do here. So for my Bx, I'm going to write that as my magnitude of force B. And then since this is the x component, automatically that is the cosine of the theta. But I have to note that theta must be in SPA, measured in SPA. Okay? And for the other a sub x, that will just be a cosine of theta. And theta will still be SPA, is equal to m a sub x. Alright? So let's first deal with b sub x, the one over here. So when we deal with b sub x, what we will be getting is, in terms of SPA, we try to substitute the the thetas here. So what happens is you have b cosine, the theta in SPA is 45 degrees. So that will look like that, plus a, the cosine. So what is this angle over here? So I know from the given, or we know from the given, that this is 30 degrees measured from the negative x-axis towards the positive y-axis. However, that is not the angle that we will be using since we want, or we should use SPA. So if that is the case, then from this going to this angle is from this point up till this point, this is already 90 degrees. So 90 plus this is 60. So that is 150 degrees. So that means to say that what you should be writing here is not cosine of 30, but cosine of 150 degrees is equal to m a sub x. Now again, why did we not take into account that ax will be negative? Sir, dapat it should be negative ax na siya. Again, as I've said, we are using SPA. And SPA, if you plug in your calculator, this cosine 150 will register already a negative value. That is why we just add plus AX. We disregard its negative because the negative is already implied in the value of cosine 150. So I'm hoping that is clear to you because I've been keeping on repeating that also from problem B. All right, so that is your we call this your equation 1. However, if you try to analyze also, we can further simplify this. Take note that with respect to this point, there are no movement, so the acceleration clearly on point 1 is 0. So that will give us a simpler equation. This will just be 0. So our final equation for this case will just be b cosine of 45 degrees plus a cosine of 150 degrees is equal to 0. And that is our equation 1 over there. So let me just put that in box. Alright, so we are done with our first equation for, of course, for free body diagram number 1 along the x. So meron pa tayong kulang along the y-axis. Still on the free body diagram number 1. Okay, so the sum, let's start again. The sum of the forces, this time around along the y, is equal to the mass acceleration along the y. So what are the forces which exist along the y? So from our free body diagram, that is why it's very crucial to have the free body diagram in the correct na arrangement of the forces, because if sa'yo imong free body diagram, automatically the sum of the forces will be also incorrect because you're basing your summation of forces from the free body diagram. Okay, so what are then the forces along the y-axis? So I'm gonna use this green. So clearly we have b sub y, and okay, I'm just gonna write it first. So I have b sub y, and then the other force is a sub y. So plus a sub y. So I'm still gonna use SPA, so I don't have to take into consideration the direction first. For the angled na mga or dahil mga angle class, that only holds true for na ay mga components kumbaga ba along x and y axis katong you disregard the sign of the force. And then the other force that is on your y axis is your C, and that is the tension on chord C. And take note that is going downward, so that means to say that will be written as negative C, sorry, negative C is equal to m a sub y. Now again, maotong gingon ako no, I'm hoping that is clear. We only disregard the direction of the force when we are dealing with vectors nga naay components. That means to say vector B na siya component, si vector A na siya component. So that means that is where we disregard the force whenever at the direction of the force whenever we are using SPA. But for those nga mga walay component nga force along both x and y, for example, the case of C in this case, kini siya, wala man na siya component along x and y, we take the direction, the appropriate direction, which should be downward or negative, just to avoid confusion on your part. So this is a sub y. So b sub y will just be b. The y component is automatically, as long as we are in SPA, that should be the sign. Plus a sub y automatically in SPA, that should be the sign. Alright? So minus c is equal to m a sub y. Now the sign of theta in SPA for b is clearly, as you can see there, this angle over here is 45. Kasi SPA, it's measured from the positive x-axis. So we have B, the sine of 45 degrees plus A sine. So what's the angle that we are going to use for vector A? The vector A is the one in blue over here. So clearly we are going to use the SPA measured from, I keep on repeating this, from the positive x-axis over here, and measure that angle taman sa mo abot ka sa imong, or you reach your vector A, and that is clearly 150 degrees. Right? So 150 degrees, so you write that one, A sine of 150 degrees minus tension C is equal to M A sub Y. And the same logic, there are no acceleration along X, nor there is any acceleration along Y. Wa siya galihok, so the acceleration is just 0. So we have now a simpler equation, which is B, the sine of 45 degrees, plus A, the sine of 150 degrees, minus C is equal to 0. So we call this our equation 2. So let me just have it in square. Not really square, but boxed rectangle. Is rectangle a square? No, it's not a square. But a square is a rectangle. Anyway, so yeah, let's have that one. So we have these two equations already set for free body number 2, and just for review, we are talking of the body 2 kining suspended weight nimo. Clearly, it's very easy to see that there are no forces along X, so you just have the sum of the forces along X, that is just 0. So that's very easy to see, kaya wala may mga interacting forces along X nimo. You can also see that from your free body diagram up above. So for the sum of the forces along Y, in this case, as you can see from the free body, there are forces along Y. So the sum of the forces along Y for free body number 2 is equal to M, by the way, M of mass 2, the suspended mass, acceleration along Y. So what are the forces? First, we have C, right? C is directed upward, so that should bear a positive sign, C. And then the other force over here is your weight. So since it's directed downward, minus W is equal to M to A sub Y. Alright, so C, I'm just going to break down the W into mass of 2 multiplied by the acceleration due to gravity is equal to mass of 2 acceleration along Y. And you also note that it's only hanging. There is no motion with respect to the y-axis. So the acceleration is just 0. So this is telling you that you have this equation. C minus M2G is equal to 0. And this is your equation number 3. So I'm just going to box it out. And you have there your summation of the forces in equation. Now, as you can see also here, class, there are other means of using this one whenever you don't want to use SPA. So you can actually do that also by utilizing your saw and ka functions. So I will not demonstrate it here, but maybe if you're interested, try to ask me during the face-to-face na patay short discussion before the quiz on this one. Okay? Katong gusto ka dili ka mag-SPA. Basically, you will still arrive at the correct answer, the same answer. Alright, so this is for your problem C.